Now, in common emitter configuration, now we are drawing output characteristics of the common emitter transistor. Output characteristics of common emitter transistor. In a transistor, this is your emitter and this is your base and this is your collector. So, there is a input base emitter. So, always there is a potential between base and emitter, that is your VBE, base emitter voltage. Simply a naked transistor. In a transistor there is a potential between base and emitter, there is your VBE, and between collector and emitter there is a potential, we can say that collector emitter voltage, that is your VCE. You must know there is a potential between base and emitter, there is a voltage, base emitter voltage, and between collector and emitter there is a collector emitter voltage, that is your VCE. So, already I told you there is your base current, emitter current and collector current, that is your IB. IB means it refers the base current, and IE, that is your emitter current, and IC, that is your collector current. In output characteristics curve, there is your output current. Output refers to collector terminal, current is your output current, that is your collector current. So, y axis must be your collector current, x axis that is your voltage. We can say this is your VI characteristics or output characteristics of common emitter transistor. Output characteristics of a common emitter transistor. So, or we can say that it is an VI characteristic of common emitter transistor. VI means voltage current characteristics, VI. So, VI characteristic of the common emitter transistor or output characteristic of the common emitter transistor. So, there is a input characteristics and there is an output characteristics. So, performance of the transistor can be judged through its characteristics. As far as output characteristics, so y axis is your collector current, collector refers to the output, the current must be collector current, x axis must be voltage, voltage is nothing but your what? Collector emitter voltage, that is your VCE, and this is your VCE, collector emitter voltage. If you are going to draw input characteristics and output characteristics, input characteristics or VI characteristics, input current, if I will draw the input characteristics, so y axis input must be what? Base current IB, voltage is nothing but is your VB. Similarly, in output characteristics, output refers what? Collector terminal, that is your IC, and voltage is nothing but what? VC at constant, but the constant emitter current, constant base current. So, transistor is a current control device. Current, what do you mean by the current control? So, output voltage increase or decrease by your input current, that is why it is called the current control device. So, there is an amplification factor in common emitter transistor, there is an amplification factor. In common emitter there is your beta, in case of common emitter there is your alpha. In common emitter configuration the amplification factor is your beta, it is very important. When you are going to buy a transistor in a market, in a specification sheet the beta value must be given. The beta value varies from in common emitter transistor 50 to 200 like this. Some transistor may be 50, another is 100, 150 like this. Same beta value cannot manufacture lakhs of transistors. So, it cannot be controllable. So, beta value vary from the transistor to transistor. Same manufacturing company, same person cannot make transistor fixed value of beta. So, it is an inherent variation of the beta. So, beta is an amplification factor of the common emitter transistor. So, beta amplification means what? Already I told you there is a gain, voltage gain, output by input. We can say that is a current amplification factor beta. So, beta in common emitter transistor, beta, that is your output by input. Tell me which is your output current, which is your input current. This is your input and this is your output. In common emitter configuration, there is your output is your IC, output current is your IC, and input current is your IB. So, I can say that beta equal to how much? Beta equal to output current IC, input current is your IB, IC by IB, or IC equal to, collector IC equal to beta IB. Look at this here, this is your output current IC, input current is your IB, output current increase or decrease by the input current IB. If IB will be increased, then IC will increase. So, beta value is fixed. The output current can be controlled by your input current IB, that is why it is called the current control device. Here in output characteristics, output is your in y axis there is your output current IC, x axis is your VC at constant IB. The graph will like this. Here let IB equal to 5 microampere, IB equal to 10 microampere, IB equal to 15 microampere, like this. So, this is your output characteristic of a common emitter transistor, output current versus collector emitter voltage at constant IB. So, then another is your load line. What do you mean by the load line? Load line, what does it mean? Load line, load line, this is your load line. We can say this is your load line. What does it mean? It is very, very important as far as transistor bias is concerned. Load means what? It refers to the output, means output there is a resistance RC. So, if the current flow in the output, there will be a drop. The drop is nothing but there is a potential difference developed across this resistor, that is your ICRC. The line, that means the line, this line we can say this is a load line. What does it mean? What does it impedance? If this load line, I can, that means this line refers a certain equation. With the help of this equation, I can draw this line. So, how will you get this equation? If you apply here, there is a loop. This is a closed circuit or mesh or loop. If you apply a loop, means Kirchhoff's voltage law at the output loop, and you will get an equation, and this equation, this line obeys this equation. First of all, if you apply KVL at this output loop, if you apply KVL, Kirchhoff's voltage law, KVL, apply Kirchhoff's voltage law to the output, tell me, what do you mean by KVL? Kirchhoff's voltage law, algebraic sum of the potential in a closed loop or mesh is 0. If there is a resistance, you must multiply it with current. If there is a voltage, as it is, means voltage, that means you will calculate sum of the voltage in a closed loop or mesh is 0. Algebraic sum of the potential in a closed loop 0. Look at this loop, there is no resistance here, there is only one resistor, that means you must multiply current, which current flow through the resistor, that is important, current into resistance, and there is a voltage source VCC and there is no resistance. And if you apply KVL in the output, always keep in your mind there is a potential between base and emitter, that is your VB, and there is a collector and emitter, there is a potential VC. So, that is why this your VB base emitter voltage, you just know there is a potential between base and emitter, that is your VB, and between collector and emitter there is a potential collector emitter voltage, that is your VC. If I will apply KVL in the output loop, tell me, if you will apply KVL, means there is a minus terminal and this is your plus terminal. If we go from minus to plus, the sign convention, that will be plus. If you go from plus to minus, that will be minus. So, if I go through this loop minus to plus, so that means this is your VCC here. Look at this is your current entering plus and leaving minus. The current is flowing in the anticlockwise. Anticlockwise means here the resistor, the current entering and this is your leaving, this is your plus, this is your minus. The resistor, this is your output resistance RC. Which current flow through this RC? That is your IC. When you are going to apply KVL, if there is a resistance, what amount of current flow through the resistance, that is important. So, algebraic sum of the potential in a closed loop or mesh is 0. So, there is your voltage means keep as it is, this is your VCC plus VCC minus to plus plus, then plus to minus minus, that is your ICRC, VCC minus ICRC, then here there is a plus and this is a minus. That potential you should remember, there is a collector and emitter, there is a voltage you should take into account. Vc minus Vc equal to 0, or I can say VCC minus VCE equal to ICRC, or VCC minus VCE minus ICRC, or we may say VCE equal to VCE means collector emitter voltage equal to VCC minus ICRC. This is an equation. This equation refers, this is your output equation. Remember, this is VCE equal to VCC minus ICRC. Already I told you operating point or Q point, the zero signal values of IC and VC, it is very important, the point where the transistor will operate, or that is your IC and VC. If I will tell you what is operating point means, indirectly you must know what is your IC or what is value of VC. Here VC, if I am applying here KVL, the output equation is your VC equal to VCC minus ICRC. This line, tell me, this line at this point, this is your VC, x axis is your VC, y axis is your IC. At this point, IC is 0 or not? At this point, IC equal to 0. Our equation is VC equal to VCC minus ICRC. If IC equal to 0, this point, IC equal to 0, VC value is how much? VCC. So, at this point, the value will be here, that is your VCC. We can say this is your cutoff point, means the current is 0. When the current is 0, maximum voltage is nothing but VCC. If the current is 0 means the maximum voltage, that is your VCC. At this point is your VCC. At this point, tell me what is the value of VC? This is your VC axis. At this point VC equal to 0 or not? If this VC value equal to 0, if the VC equal to 0, what does it mean? VC 0 equal to VCC minus ICRC, 0 equal to VCC minus ICRC. IC value is how much? 0 equal to VCC minus ICRC, or IC equal to how much? VCC by RC, IC equal to VCC by RC. So, that is, so when VC equal to 0, IC equal to 0, VC equal to VCC, when VC equal to 0, the value of IC is how much? The IC equal to VCC by RC, VCC by RC. It is very important. This is your cutoff point and this is your saturation point. We can say that this point is your cutoff point, and this point we can say this is your saturation point or IC sat. In saturation point, when the transistor is in saturation, at that point remember that VC value is 0, collector emitter potential will be 0 and maximum current will flow, that is your VCC by RC. That is your saturation current and this is your cutoff voltage and this is your saturation point, meaning maximum current will flow. And this line, this is called the load line. Load line means the load line, the obeys the output equation, that is your VC equal to VCC minus ICRC. With the help of this equation, I can draw this line, this is called the load line, and simply this is an output characteristics curve. When this load line intersect the output characteristics, and these are the operating point. The intersection point is called the operating point. These are the possible operating point, that is your, this is your A, another operating point, that is your B, and this is your C. So, that means A, B, C, these are the possible operating points. Operating points already I told you means what is the value of IC and what is the value of BC. If this A as your operating point, tell means what at this point what is the value of IC and what is the value of BC. That means it is close to the saturation part. That means that much value of IC, this is the that much value of IC, and if you draw the perpendicular here, this is your VC. That means the current is maximum and the voltage is minimum here. If B as your possible operating point, if B as your possible operating point, this is your that much value of IC and that much value of BC. If C as your operating point, that is your, that if you draw the perpendicular to both x axis and y axis, the minimum value of IC and the maximum value of BC. So that means the transistor will operate at a particular value of IC and VC. If I will choose A as your operating point, what will happen? So transistor as an amplifier. If I am giving the input signal, you will get this is your input, the output you will get the amplified signal. If A as your operating point means maximum current and minimum voltage, what will happen? What will be the waveform obtained at the output? If we will choose A as your operating point, some part of the positive half cycle of the input, some part of the negative half cycle of the input signal will be clipped. That means like this. So transistor the input signal is not properly amplified. If I will choose A as your operating point, some part of the negative half cycle of the input signal will be clipped, removed or disappear. If C as your operating point, if C as your operating point, that means minimum current and maximum voltage, some part of the negative half cycle of the input signal clipped. If A as your operating point, what happen? If A as your operating point, if I will choose A as the operating point, some part of the positive half cycle of the input signal will be clipped. That means this part will not get at the output. So transistor as an amplifier means the properly amplified output must be obtained. So the suitable operating point must be B, means middle of the load line. This is your load line. The operating point should be selected middle of the load line, so that no part of the input signal will be clipped. So that's why the operating point should be selected middle of the load line. The operating point should not be disturbed. That means the operating point should not be shifted to the saturation region and should not be shifted down to the cutoff region. So the operating point, how to stabilize the Q point? If you will stabilize the Q point, alternatively you will get the amplified output obtained at the output, amplified signal obtained at the output. If you will not get stabilize the operating point, means there might be a chance the operating point may be shifted toward the cutoff region, and that operating point may be shifted down to the saturation. So saturation region may be shifted down to the cutoff region. So how to stabilize the Q point? That will be important. To stabilize the Q point, we have to follow a proper biasing method. If you select the proper biasing method, you can stabilize the Q point. Once you stabilize the Q point, the fixed values of IC and VC, you will get the properly amplified output signal. So that's why how to stabilize the Q point, that is important. So this is all about Q point, and already I told you Q point is nothing but zero signal values of IC and VC. Next one is your stabilization. Stabilization. What do you mean by stabilization? So already I told you the values of IC and VC, the zero signal values of IC and VC is your Q point. How to stabilize your Q point? As far as stabilization is concerned, in case of transistor, so there is this is your emitter, this is your base, and this is your collector. This is your potential between base and emitter, that is your VB. The potential between collector and emitter, that is your VC. So VB, there is your input potential or input voltage. This is your threshold voltage. We can say that in VB, this is your base emitter voltage. VBE is your base emitter voltage. VBE or knee voltage. This is your 0.3 volt for germanium and 0.7 volt for silicon. In germanium transistor or silicon transistor, the knee voltage VB means base emitter voltage should be mentioned when you are going to buy, when you are going to market to buy a transistor. There is a VB mentioned. VB beta will always mentioned. VB equal to 0.3 volt if it is germanium, 0.3 or silicon 0.7 volt. So there is a base emitter voltage, there is a VB, and there is a collector emitter, there is a VC. What do you mean by stabilization? So in a transistor, VB base emitter voltage, when there will be a condition will arise, that is called the thermal runaway. Thermal runaway. Thermal runaway. What does it mean? When the transistor operates, heat is developed within the transistor, means temperature increases, When the temperature increases, then leakage current will increases, that is your ICBO. What is leakage current? I will tell you. Leakage current increases. When the leakage current increases, so another is your IC increases. Again IC increases, again temperature increases, and the matter of second transistor will burn. The concept, you must know what is the leakage current, ICBO. Leakage current or reverse saturation current. Leakage current or reverse saturation current. Reverse saturation current. Leakage current or reverse saturation current. This is your ICO or ICBO. Collector to base current when emitter is open. 3 terminal, collector, base and emitter. Collector to base current when emitter is open. This is your emitter, this is your base and this is your collector. When collector to base current, this is a common base configuration. This is your emitter, this is your base and this is your collector. Collector to base current means this is your output when emitter is open, this is your open in common emitter common base configuration. So, this is your collector and this is your base. Base is common between collector and emitter. Collector to base current when emitter open. When the input open, there is no chance the current flow in the output loop. When the input open, there is no output current. But due to some minority charge carrier, due to minority charge carrier, very negligible amount of current flow in the output, that is called the leakage current or reverse saturation current, that is your ICBO or ICO. It have a great impedance in a transistor biasing or a transistor as an amplifier. This leakage current, when the transistor will operate, heat is developed within the transistor. In heat development means temperature increases. If the temperature increases, the leakage current also increases. In a leakage current, ICBO or ICO, every 10 degree centigrade rise in temperature, ICO doubles. In leakage current, every 10 degree centigrade, concept of, you can just know the concept of ICBO, concept of ICBO. Collector to base current when emitter open. When the input open, there is no chance the current flow in the output loop. Due to some minority charge carrier, the current in the flow in the output, that is called the leakage current. So in leakage current, every 10 degree centigrade, rise in temperature, ICO doubles, ICBO doubles. When the temperature developed within the transistor, when the transistor will operate, every 10 degree centigrade ICO doubles. Suppose initially the ICO is 10 microampere, again 10 degree centigrade, the ICO will be 20, again 40, again cumulative process, matter of second transistor will burn. So how to control the leakage current, that is important. To control the leakage current or reverse saturation current, proper biasing method, the stabilization is necessary. So one of the key parameters, is your leakage current or reverse saturation current, that is fully dependent on the temperature. When the temperature increases, ICO increases. When the ICO increases, again IC increases. When IC increases, again the matter of second transistor will burn. So every 10 degree centigrade rise in temperature, ICBO doubles. This is the concept of leakage current. Then VB, another one is your base emitter voltage VB. So base emitter voltage VB, there is a specification sheet. So it is also dependent on the temperature. When the transistor operates, heat is developed in the transistor, means temperature increases. If the temperature increases, so VB decreases. The VB decreases every 25 millivolt per degree centigrade rise in temperature. Look at this. These two criteria is very important. One is leakage current, that is due to temperature increases. One is your reverse saturation current ICBO, another one is your VB. If the base emitter voltage decreases, means minimum voltage required for a transistor to conduct, that is your 0.3 volt or 0.7 volt. If the input voltage is below 0.3 volt, if German wave transistor, the transistor will not conduct. So, if the Vb decreases, means the transistor will not conduct. If will not follow a proper biasing method, that means the transistor will not operate properly. The proper amplified output will not get. So, that is why if we will follow a proper biasing method, so that if the temperature increases, that will not, that it should be independent of the variation of the what, Vb and leakage current. So, it will be, if we will follow the proper biasing method, if we will stabilize the Q point, ultimately we can stabilize the leakage current ICBO and also Vb. Okay, thank you.